Hello all, I'm back with another video. So this one is from the Pearson Edexcel Level 3 GCE, and it's called Core Physics 1, and it's from the AS, the Advanced Subsidiary level. This is probably a paper that is taken by year 12 students in England and elsewhere, wherever this curriculum is followed. For those of you guys who are taking the international Edexcel physics, this paper feels a little bit like Unit 1 combined with Unit 2. And in this curriculum, they also have lenses, which is not in the international curriculum. But I mean, I think it's useful to a variety of audiences. So let me know actually who is taking this test. In England, it's probably year 12 students, and it's the AS level, and it comes in two papers, paper 1 and paper 2. And then at the A level, there is paper 1, 2, and 3. So anyway, so this is Core Physics 1. Let's dive in and let's go. Okay, section A includes 8 multiple choice questions that award 1 mark each. And as I said in previous videos, and for those of you who are new, I always say that whenever a problem awards 1 mark, it should take you about a minute to solve. And in the problems that are written problems, if a problem awards 5 marks, it should take you about 5 minutes, and so on and so forth. So section A includes 8 multiple choice questions and 8 written questions. And section B includes 2 questions written. Okay, so it's slightly different from the international curriculum. So anyway, let's go. Question 1. A ball bearing falls from rest through oil. Which of the following statements is correct during the initial motion of the ball bearing? So the resultant force on the ball bearing decreases. Okay, so first of all, to answer this, we have to draw a free body diagram. Let's use a clean page. So this is the ball bearing, and let's say it falls through some oil. So what are the forces on this ball bearing? First of all, it's you have the weight acting down, the upthrust that points upwards, and then the drag force that also points upwards. Okay, actually, you should draw them like this with the with the drag force and the upthrust like that, because the upthrust is usually a larger force. So now the weight is mg, the upthrust is rho, the density of the fluid, times g times the volume of the ball, because this is the upthrust is basically the weight of the displaced volume of liquid. So, but the drag force is the Stokes force, right? Okay, which is 6 pi times the viscosity times the radius of the sphere times the velocity. Okay, and this is the key here. Okay, so the drag force depends on the velocity. So as the velocity increases, drag increases, but sigma f decreases, right? Because if the ball moves down, the sum of all forces is weight minus upthrust minus drag. Okay, weight and upthrust are constants. I mean, they don't depend on velocity, right? Only drag depends on velocity, and as the velocity increases, drag increases. Therefore, sigma f decreases. Okay, I hope this makes sense. Therefore, A is the correct answer actually. Okay, so but we can read the rest. B, the resultant force on the ball bearing increases. We just showed that it does not. Okay. C, the resultant force on the ball bearing decreases, then increases. This makes no sense. And then D, the resultant force on the ball bearing stays constant. This is not the case. This would be the case if you ignore the drag force. Okay, so if there was no drag, okay, then you will just have the upthrust and the weight, which are constants. They don't depend on velocity. Therefore, the sum of all forces will be constant. Okay. All right. Question 2. And again, for those of you who are new, I say this in most of my videos. I work out my own solutions. Sometimes I look through the mark scheme, but most of the times I don't. I follow my own solutions and I try to explain what's going on. Okay, so this is the way I work through papers. Okay. Question 2, as the temperature of a negative temperature coefficient thermistor increases, the resistance of the thermistor changes. Which of the following statements is correct? So the resistance decreases as lattice ions vibrate with decreased amplitude. This doesn't make sense because the lattice ions would vibrate with an increased amplitude if you increase the temperature, so that's wrong. B, resistance increases as lattice ions vibrate with increased amplitude. Okay, kind of. Okay, actually, sorry, I think I misled you. So the resistance increases as lattice ions vibrate. Okay, they do vibrate with increased amplitude if you increase the temperature, and but the resistance in the negative temperature thermistor actually decreases because of C. Okay, so B feels kind of correct, but the resistance of a negative temperature coefficient thermistor decreases as we increase the temperature. So C is the correct answer because it says resistance decreases as the number of conduction electrons increases. Okay, so that's the correct answer. Okay, B could have been correct for maybe a filament lamp or something like that. So anyway, and then D, resistance increases as the number of conduction electrons decreases. That's wrong because as we increase the temperature, electrons move more freely. Okay, and the conduction electrons increase. Okay, 3. Which of the following units is equivalent to a Newton, to the Newton? Okay, so the way to work this out is to write a formula that involves newtons. Okay, so that's F equals ma. Okay, and this square brackets denotes that we are working with the units of each physical quantity. So the newton is equal to the kilogram, which is the unit for mass, and the unit for acceleration is meters per second square. And we can read immediately that the correct answer is B. Okay. Question 4. A circuit consists of a cell of EMF 1.5 volts connected to a 100 resistor. A voltmeter is connected across the 100 ohms resistor as shown. The voltmeter reading is 1.45 volts. Which of the following gives the internal resistance in ohms of the cell? Okay, so let's write down a few things. So the voltage across the terminal is equal to the EMF minus the current in the circuit times the internal resistance. Okay, and this is because power supplies have some internal resistance, right? And then we can actually calculate the current in the circuit using I equals to V over R. Okay, what is a V? 1.45. Okay, so we are calculating I by using the information from here. Okay, so I is the voltage, which is 1.45 over the resistance of this resistor, which is 100, right? Now let's see how we can use this. Let me think. If we okay, we calculated the current and we can plug it into there. Okay, so what's the voltage? It's 1.45 again, right? Because it's measured from the voltmeter, and this should be equal to the EMF minus I times the internal resistance, right? So IR is E minus 1.45, and then what is E? What is EMF? It's given as 1.5 volts, right? So R is 1.5 minus 1.45 over I, but I was calculated to be 1.45 over 100. So the correct answer is, where is it? A. Okay, I hope this makes sense. So we start from here. We use the voltmeter reading to calculate the current, which we do using this formula. I'm just boxing, okay? And then we know that across an amp, the voltage is given by the formula shown in the red box, amp minus IR, and we just solve for R, which is the internal resistance. Okay, question 5. And by the way, in all the videos, I also say that if something doesn't make sense, guys, you can comment on the video and I always reply. So, okay, the graph shows how the displacement S varies with time t for an object. Which of the following graphs shows how acceleration A varies with time t for the object? Okay, since we are given the displacement time graph, we know that the gradient of the displacement time graph is the velocity. Okay, so let's go see what's going on with the velocity. So over here, basically the gradient is the tangent to this curve. Okay, so the tangent down here is this line. Okay, so that's the velocity at time, say 0, then at time, say whatever this time is, maybe 3 seconds or something, I don't know, the velocity actually decreases, right? And if we take the tangent at a different time, the velocity decreases again. Oops. So let's take the tangent there. Okay. And if we take the velocity at yet another time, we see that it kind of becomes 0, like the tangent kind of becomes 0. So the velocity decreases, right? So it starts with v large, right? And then we end up with v approximately equal to 0, right? So all across this displacement path, or all across this path, the velocity keeps decreasing. And the only way for that to happen is to have a negative acceleration, also known as deceleration. Okay, so the only possible answers are B and C. Okay, now which one is it? Is it C or is it B? Let's see. If we focus on this part, sorry, something funky happened with my screen. So if we focus on this part of the motion, then the gradient is constant, right? So the velocity, this part tells you that the velocity is constant, okay? Which means, by the way, my handwriting is horrible, guys, I'm sorry. So constant. All right, so if the velocity is constant, the acceleration is 0, right? So the only possible answer is B. Okay, I hope this makes sense. If it doesn't, let me know in the comments. Okay, let's move on. Question 6. A stone is dropped. Yes, okay. A stone is dropped from rest down a well. The sound as the stone hits the water is heard 3.5 seconds after the stone is dropped. Which of the following gives the distance in meters traveled by the stone before it hits the water? And let me make a comment here, which might be useful. You know, sometimes, as I say, there is the lawyer's way to solve a problem. And how do lawyers work? They eliminate whatever doesn't make sense to arrive at the truth, right? So let's try this. So here, answer B includes the acceleration due to gravity, which is expressed in units of meters per second squared. And then 3.5 is the seconds, right? So, so answer B expresses velocity in meters per second. So that's automatically wrong because in this problem we are calculating a height, right? So that's wrong. Then answer C. In this answer we have meters per second squared times second squared. So that's a possible answer. Then if we look at the answer D, we have 3.5, so seconds squared is in the numerator, and then in the denominator we have meters per second squared. So this answer is expresses something that has units of seconds to the fourth over meters, so that's totally wrong as well. And then answer A is a plausible answer because it expresses a height. Okay, so immediately we eliminate 2 out of the 4. okay, just by looking at the answers. Actually, I'm not going to erase it. I'm going to leave it there for those of you who want to study it. So anyway, we can use the Suvada equations, right? And S is given as the initial velocity times time plus 1/2 at squared, right? And then a stone is dropped from rest, therefore the initial velocity is 0. So we can see immediately that the answer is 9.81 times 3.5 squared over 2, which is answer A. Okay, I just wanted to show you guys that you can actually eliminate some of the answers sometimes. Okay, 7. A wire of decreasing diameter is connected in a circuit. There is a current from X to Y in the wire as shown. Which row of the table gives the current and the drift velocity of charge carriers at Y compared to X? Okay, so the current is given by the number of charge carriers times the charge times the drift velocity times the cross-sectional area. So if we solve for the drift velocity, we find I over NQA. Okay, so at Y, the cross-sectional area, because you can think of this as something that has a cross-sectional area, right? At Y, the cross-sectional area reduces, so A reduces, therefore V increases, right? And then nothing happens to the current. I mean, you will have as much current flowing at X as you have at Y, okay? So the correct answer is C, okay? And the best way to visualize current is to think of a pipe carrying water, right? When the pipe gets, let's say, when the pipe decreases in cross-sectional area, then the water flows faster, right? So it's the same thing. Okay. Then 8. A shopping trolley moves at velocity v. The trolley collides and combines with a stack of 5 identical stationary trolleys. Which of the following expressions gives the velocity of the combined stack of trolleys? So you have a trolley, okay, something like this. I'm sorry, I'm not the best in drawing. Okay, and then it moves with velocity v, and it collides with how many? 5. So 1, 2, 3, 4, 5 stationary trolleys. Okay, so their mass, so the mass of this thing is m, the mass of these things is 5m, right? And this is before and after they all stick together, so all 6 of them. Okay, so 5, 6, okay, and since they all combine together, they will have a mass of 6m and a new velocity v prime. Momentum is conserved, so what's the momentum before? It's m times v plus 5m times 0, since they are stationary, and the momentum after is 6m v prime, right? So we have mv is 6m v prime, mass cancels, so v prime is v over 6, and that's answer D. Okay, question 9. The graph shows how current varies with potential difference for a component in a circuit. Explain how the graph shows what the component is. So first of all, let me write down Ohm's law. Okay, so I is 1 over R times V. Okay, so the gradient of an IV curve yields 1 over the resistance. Okay, so keep that in the back of your heads and let's go answer. So as V as the potential difference, let's write as potential difference. Okay, potential difference is V and current is I. Okay, so as potential difference increases, okay, the current increases, right? at a decreasing rate. Okay, so at a decreasing rate. What do we mean by that? Notice that if we increase the potential difference by, say, this much, okay, the increase in the current is, let's see, is this one, okay, between here and there. And then if we increase the potential difference a little bit more, okay, so let's say we come up here, the current increases a bit, but it increases in a decreasing rate. Okay, so that's the first observation. Okay, I hope this makes sense. If it doesn't, let me know. Okay, the second thing we can observe is that equal increases in potential difference give smaller and smaller increases in I, which is basically the same thing we wrote in the first sentence, but okay, I mean, I wrote it again. I don't know why I did this in my notes, but anyway, I did it. So R increases as IV increase. Okay, and how do we know this? Because the resistance is the gradient of this curve, right? So initially the resistance is constant, but notice that here the resistance increases because the resistance, okay, actually here the gradient is 0, okay, but the gradient is 1 over r, right? The gradient is equal to 1 over r. This is the gradient. So the 1 over r is 0, which means that r is practically almost infinity. Okay, so the resistance actually increases as the current and the voltage increase. So what kind of element is this? It's a filament lamp. Okay, so this is a filament lamp. Bulb, actually, this is the correct way. Filament bulb. Okay, hope this makes sense. Let's move on. Question 10. A person pushes a baby in a pram. The person pushes the pram with a constant force. The force is applied at an angle of 50 degrees to the horizontal as shown. When a force of 35 newtons is applied, the pram moves at constant speed. Calculate the work done to push the pram at constant speed for 500 meters. Okay, so this is the force. Let me draw it. Okay, so the force is this one, and we can analyze it into a horizontal component. Let me use green. Okay, which is equal to 35 newtons times cosine of 50 degrees. Okay, which is equal to 22.5 newtons. And we also have a vertical component. Okay, this one, which is equal to 35 newtons times sine of 50 degrees. The way to tell whether a component involves sine or cosine is the following. So this one is a sine, the vertical component, because the component, so this guy, the vector, does not touch the angle 50, whereas the cosine 50 does touch the angle. Okay, so that's how I remember things. Okay. Anyway, so this is 26.8 newtons, but work is only done by forces that move in the same direction as the displacement. Okay, so the vertical component of the force doesn't produce work. Okay, so the work done is equal to F times cosine of 50 degrees times 500 meters, which is the displacement, So this is 11,250 joules. Okay. B. The pram is then moved along the same surface at the same constant speed by a different person. This person pushes the pram by applying a force horizontally as shown. So, yeah, I mean, she has her hands in this direction pretty much. Okay, explain how applying a force horizontally changes the magnitude of the force needed to push the pram at the same constant speed. So we just showed pretty much that we only need 22.5 newtons of horizontal force to push the pram by 500 meters at constant speed. Okay, whereas this guy uses 50 newtons. So, sorry, 35 newtons. So this is the answer, I guess. So if we push horizontally, we only need 22.5 newtons instead of 35 newtons, right? So a lower applied force, produces the same result. Okay, let's move on. Question 11. Two resistors are connected in series in a circuit as shown. The power supply has negligible internal resistance. A. Calculate the resistance R of the resistor when the voltmeter reads 5.5 volts. So we need to calculate this guy. Okay, so let's first calculate the current. So R is voltage over current, right? So I is voltage over R. I don't know why I keep writing this over and over again, but anyway, okay. So if we use this part of the circuit, then the voltage is 5.5 volts and the resistance is 45 ohms. Therefore, we get 0.12 amps for the current. Okay. Now, the total resistance should also obey Ohm's law. So should be equal to 15 volts, which is the power supply, over the current, which is 0.12, right? Or the total resistance is 125 ohms. But the total resistance is equal to R plus 45 ohms because they are in series, right? And this is equal to 125 ohms. Therefore, R is 80 ohms, and that's the answer. All right. B, a student uses the circuit to power an electric motor. He connects the motor in parallel with the 45 ohms resistor. The electric motor has a resistance of 45 ohms and a normal working potential difference of 5.5 volts. Deduce how the motor performs when connected to the circuit. You do not need to do a further calculation. So let's write down a few things. So adding the motor in parallel reduces the resistance of that part of the circuit. Okay, and by that part I mean this part. Okay, the total current in the circuit increases. Okay, the potential, I'm gonna use a clean page. The potential difference, the PD across R increases. So the potential difference, the PD, and how do we know this? That the potential difference across R increases because the potential difference is I times R, right? So if I increases, the potential difference across R increases. Therefore, the potential difference across the parallel combination decreases. Okay, so the motor will get less than 5.5 volts, so the motor will run slowly, and that's the answer. All right, question 12. Two people are carrying a bookcase. They are holding the bookcase at points A and B as shown. The length of the bookcase is 1.5 meters. The center of gravity C of the bookcase is 0.55 meters from one end. The people exert forces FA and FB on the bookcase at points A and B as shown below. Calculate FA and FB, and they give you the mass of the bookcase. So FA plus FB should be equal to m times g, right? This is equation 1. And also, if we take moments around C, we have that FA times 0.55 should equal FB times 0.95, okay? Therefore, FA is 1.73 FB. This is equation 2. If we combine 1 and 2, we find that 2.73 times the force FB is equal to m times g. So FB is 25 times 9.81 over 2.73, which is equal to 90 newtons. Okay, and if FB is 90 newtons, then FB is 155 newtons, and that's the answer. Okay, part B. The two people now support the bookcase so that it is tilted with point A higher than point B as shown. The bookcase is stationary and the forces exerted at points A and B are still vertical, so they are like this. So this is FB and this is FA. Trying to make it vertical. Okay, FA. Explain how the magnitude of the forces exerted at points A and B change. You should consider moments about point A. Okay, the weight, let me use black. So the weight of the bookcase acts vertically downward through C. So this is what I mean. Okay, so this is the weight. So its moment about A depends on the horizontal distance from A to C. Okay, when the bookcase is tilted with A higher than B, the center of gravity moves further horizontally from A, which means the weight produces a larger clockwise moment, about A, okay? So if you look at this situation, this is the horizontal distance, right? But now the horizontal distance is larger than before, okay? All right, let me use a clean page. To keep the bookcase in equilibrium, the anti-clockwise moment about A must increase. So FB must increase. And also the horizontal distance of B from A decreases. Okay, so FA plus FB must still be equal to the weight. So if FB increases, then FA decreases. Okay, so that's the answer. So again, to summarize, now the center of gravity moves away from A, therefore the clockwise moment due to the weight is larger than before. Therefore, it has to be counterbalanced by FB, which increases now, okay? And since FB increases, FA has to decrease, okay? And that's the answer. And let's move on to question 13. Okay, question 13. A textbook has the following statement about the motion of a projectile with negligible air resistance acting on it. The only force acting on a projectile is the weight of the projectile. This affects the vertical motion of the projectile, but not the horizontal motion. A ball was projected up from the ground at an angle. The position of the ball was plotted at equal time intervals as shown. Question A, explain how the diagram gives evidence to support the statement in the textbook. And this is a long writing problem with 6 marks, which again, it should take you about 6 minutes. But more importantly, in long writing or in general writing problems, if it awards 6 marks, you usually have to provide about 6 arguments for or against the statement. Okay. So anyway, the key here is to notice that if we take the vertical displacements, okay, we see that they are kind of equal to each other, right? So these are the horizontal displacements. Did I say vertical? I'm sorry. So these, and these are equal, okay? But if we try with the vertical displacements, okay, there. So notice that this is larger than this, and then the next one is this one, which you can see that the vertical displacement reduces, okay? So this is a key here, actually. So let's write down that the horizontal displacement in each time interval is the same. Horizontal velocity is that's the same. Okay, it doesn't change. The horizontal velocity is constant, in other words. And whenever we have constant velocity, it means that we have no acceleration, right? So no acceleration, hence no force horizontally. Okay, now let's turn our attention to the vertical displacement, the vertical direction. So in the vertical direction, the vertical displacement changes. Okay, let's write that. Actually, in the beginning of the motion, okay, the vertical displacement decreases, and then as it goes down, it increases, okay? But it changes, okay? That's the key observation. Hence, there is a vertical acceleration. There is a vertical acceleration. And V is not constant. Okay, and this acceleration is due to weight. So acceleration, let me fix this. So acceleration is due to weight. All right. B. The photograph shows a cannon which was used to fire cannonballs over long distances in the 15th century. A cannonball was projected over a horizontal distance of 250 meters as shown below. The time of flight of the cannonball was 7.5 seconds. Calculate the angle theta at which the cannonball was fired and the initial speed u of the cannonball. Okay, so let's do this in two steps. So first of all, the initial velocity u comes in two components, a horizontal, right, which is equal to u cosine theta, and a vertical, which is equal to u sine theta. Okay, so let's start with the vertical direction and see what happens. So if we use the Suvat equation, s is equal to the initial velocity times time plus 1/2 at squared, right? In the vertical direction, we can actually say that the displacement is 0, right? Because we start here and we end here. Okay, so 0 is equal to, what's the initial velocity in the vertical direction? It's u sine theta, right? So u sine theta times t. And then what's the acceleration? Minus 1/2 gt squared, okay? So in other words, we have that u sine theta is equal to 1/2 gt, because meanwhile this t cancels, okay? And if we plug in numbers, we find that u sine theta is 1/2 times 9.81 times the time, which is, what is it, 7.5. So this is equal to 36.79, okay? Now let's go see what's going on in the horizontal direction. In the horizontal direction, we can still use s is ut plus 1/2 at squared, right? Now this time, the acceleration in the horizontal direction is 0, right? So s is u cosine theta, which is the initial speed, times time. Okay, so u cosine theta is s over t. What is s? 250 meters, right? So this is equal to 250 over 7.5. Therefore, u cosine theta is 33.33. Okay, so if we write them together, so u sine theta is equal to, what was it, 36.79. And then if we divide this by u cosine theta, which is, and then we need to divide by 33.33, u cancels, and we see that tangent of theta is 47.82. Sorry, I took an extra step. So tangent of theta is 1.1, therefore theta is 47.82 degrees, and then thus u is 33.33 over the cosine of 47.82, or 49.64 meters per second. Okay, and that's the answer. So we found theta and we found u. So we can move on. Question 14. Since 2008, the Scottish island of Eigg, I hope I pronounced it right. If anyone is watching from this island, let me know in the comments what the pronunciation is like, okay? So in this island, the island of Eigg has generated almost all its electrical power from renewable energy sources. That's admirable. The main source of power for the island is produced by hydroelectric generators. A. Water falls through a height of 124 meters as it flows through a pipe to a hydroelectric generator. Calculate the maximum power input of the generator, and they give you the mass flow of the water in as 130 kilograms per second. All right, so the way to work this out is to write that power, which is what they ask us to find, is energy over time. What's the energy here? It's gravitational energy, so mgh over time. So we can write this as m over time times g times h. So m over time is this quantity that they give us, okay, which is kind of strange, but it works out, okay? So 130 and then kilograms times seconds to the minus 1. By the way, whenever I plug in numbers, I usually put into formulas, I plug the numbers to the left and I put all the units to the right, okay? So 130 kilograms times seconds to the minus 1, and then G is 9.81 meters seconds to the minus 2, right? And then we also have height, which is 124 meters. Let's make these meters square. Okay, so kilograms times meter squares over second squared is joules. Joules over seconds is watts. So this works out to 1.6 times 10 to the 5 watts. Okay, and I can show you actually in the clean page just to complete this. So kilograms meter squared over second squared over seconds. So this guy here is joules, and then joules over seconds is watts. Okay, so that's the answer. Part 2, explain why the power input of the generator is always less than this value. So friction, okay, so friction of water with pipes, that's the first reason, and energy lost to surroundings. Okay. B, when demand for power is low on Eigg, excess energy is stored in a number of batteries. The batteries have a total capacity of 4,400 amps hour when fully charged. Okay, that unit is actually coulombs. Okay, because we have ampere, so 1 ampere is coulombs per seconds, right? Times hours, which you can convert to seconds eventually, so that's coulombs. Okay, when demand for power is greater than the output from the renewable sources, energy is supplied by the batteries. The batteries supply an average power of 20 kilowatts, calculate the total time in hours for which the batteries can supply energy before they need recharging. And they give you the total output potential difference of batteries as 48 volts. Okay, so let's do this step by step. Recall that energy is voltage times charge. Okay, now the charge is 4,400 amps, which is coulombs per second. Actually, okay, let's do it like this. So let's put coulombs per second here, and then hours, and hours can be converted into seconds. So 1 hour is 60 minutes times 60 seconds in a minute. So we have seconds here. So the charge is 1.58 times 10 to the 7 coulombs. Okay, so the energy, let me use a clean page. So the energy, which is VQ, is equal to 48 times 1.58 times 10 to the 7, and then that's volts times coulombs, which are convert to joules. So 7.6 times 10 to the 8 joules. Now power is energy per time. So time is energy over power. The available energy is 7.6 times 10 to the 8, and that's joules. And then the power that can be outputted by the batteries. Sorry, the batteries supply an average power of 20 kilowatts. So yeah, the power that can be outputted is 20,000 watts, and a watt is a joule per second. So if we do this, if we do this calculation, we find 38,016 seconds, which is 10.56 hours. So, okay, that's plenty of time. Right, we're done with this part. Part 2, on egg, the cables to the houses are made of aluminum instead of copper. The rate of energy transfer to the environment is limited to 0.05 watts per meter of cable. The engineers claim that using aluminum instead of copper reduced the cost of the electrical cables by 90%. Evaluate this claim by comparing 1 meter length of cable made from each material. Assume the current in each cable is 22 amps. And they give you the materials, resistivity, and the cost in pounds per cubic meter. Okay. So let's think about this. So the power is equal to I squared times the resistance, right? And then the resistance of a cable is given by the resistivity times the length over the cross-sectional area. So, so the power per length, let me think, am I messing up something? So the power lost, pretty much. I mean, the power lost in a current wire is I squared over R. So the power per unit length is equal to I squared times the resistivity over the cross-sectional area. Okay, so this is the general formula we will work with. And then power per length is 0.05 watts per meter. Okay, so this is what's given. So let's go apply this formula to the two materials. So for copper, we have 0.05 watts per meter. Okay, and this is equal to to I squared, which is 22 squared, times the resistivity of copper, which is 1.68 times 10 to the negative 8 over the area. Okay, and we can therefore calculate the cross-sectional area. Okay, so the cross-sectional area for this wire is 1.63 times 10 to the negative 4 squared meters. Okay, therefore the volume for this cable will be equal to the cross-sectional area times the length, and the length is just 1 meter, so we will still have 1.63 times 10 to the negative 4 cubic meters. Okay, now the cost is 77,090 pounds per cubic meters. Let me know if I am making the pound sign correctly. Okay, times 1.63 times 10 to the negative 4 cubic meters, which is the volume of this cable. This will give us a cost of 12.54 pounds. So again, let me repeat. So they give us the rate of energy transfer to the environment, which is 0.05 watts per meter. So we use that information and the resistivity they give us along with the length to calculate the cross-sectional area of the copper wire, okay? And then we multiply with the length to find the volume, and then we multiply with the cost to find the cost. Now for aluminum, okay, we have 0.05 equal to 22 squared times 2.65 times 10 to the negative 8 over A. So A is 2.56 times 10 to the negative 4 squared meters. So the volume is A times L, which is 2.56 times 10 to the negative 4 cubic meters. Okay, and the cost will be 2.56 times 10 to the negative 4 multiplied by 6,070 pounds per cubic meter, or 1.56 pounds. Okay, so the cost reduction will be 12.54 minus 1.56 over 12.54 times 100, or 88%, which is about the same as 90%. So the engineers are right, actually. It's better to use aluminum. Okay, and cheaper. All right. This was part A, by the way. I think I made a mistake when I told you that part A has 8 multiple choice questions, and I think I told you 8 writing questions. It's actually 6. So section A has 14 questions pretty much in total, and then section B has 2 questions. So this is the first time I'm going through the AS paper, so I hope I'm doing a good job. So let me know in the comments. Question 15. A student makes a lens by filling a glass ball with silicone oil. She investigated the refraction of light through this lens. The student shone light vertically downwards through the lens as shown. A, the student measured the focal length of the lens to be 16.7 centimeters. Calculate the power of the lens. So the power is equal to 1 over the focal length. So 1 over 0.16, okay, which is 5.99 D, or about 6 D, okay, and that's the power. All right, B, the refractive index of the silicone oil changes with temperature as shown. So it decreases pretty much, okay. The student connected a light-dependent resistor LDR to an ohm meter. The light was brought to a focus at the focal point F as shown. The LDR was placed at F. So we have an LDR there. Okay. The student recorded the resistance of the LDR. She then filled the glass ball with silicone oil at a higher temperature and recorded the resistance of the LDR again. Deduce the effect on the resistance of the LDR of deduce the effect on the resistance of the LDR of increasing the temperature of the oil. So ST increases, the refractive index of the oil decreases. Okay, so now light refracts less by oil. Okay, so we have less light bending than before. Okay, so the focal length f increases. Okay, so LDR is at the old focal length, so light arriving at LDR decreases. Okay, so again light intensity at LDR decreases. Okay, so the resistance of LDR increases. I'm sorry, it increases. Okay, why is that? Because as we increase the light of an LDR, we make more charge carriers available, therefore the resistance decreases. But in this case, the light reduces, therefore the resistance increases. Okay, I hope this makes sense. Let me know in the comments again. So let's move on to question 16. So a student directed light from a laser onto a double slit. The double slit consisted of two parallel narrow slits at distance s apart. The light spread out as it passed through the double slit and hit the screen at distance d away from the double slit as shown. The light produced a pattern of bright and dark fringes on the screen as shown below. A. The student used digital calipers to measure the separation of the fringes W by measuring between the centers of adjacent fringes. Explain how the student could reduce the percentage uncertainty in his measurement of W. So the percentage uncertainty in W is equal to the absolute uncertainty in W over W. So measure for n fringes and divide by n. Okay, this increases W and hence decreases the percentage uncertainty. Okay, in other words, instead of measuring just one, measure, I don't know, 1, 2, 3, 4, 5, 6 of them or something like that. Okay, so I hope this makes sense. Let's move on to part B. The student varied S for the double slit and recorded corresponding values of W. The results are recorded below. Plot a graph of S on the y-axis and 1 over W on the x-axis using the grid opposite. Use the additional column in the table for your process data. Okay, so we need another column with 1 over W. The units are meters to the minus 1. So 15.15, 33.22. I'm gonna speed up the video. All right, the column is complete. Let's move to the plot. Oh, before we move to the plot, let's notice that, okay, the range in S is from 0.1 to 0.5, so increments of 0.1 work. And the range in 1 over W is from 15.55 to 76, so increments of 20 are kind of good. So we can, yeah, let's go to the plot. So this is S in 10 to the negative 3 meters is the unit, okay? And in this axis we have 1 over W in meters to the minus 1. So Let's start from 0 for 1 over W, 20, 40, 60, 80, and then 100. And then again from 0 for S, so this is 0 0.1, 0 0.2, 0 0.3, 0 0.4, and 0 0.5. And let me work out just one pair of values, and then we will speed up the video again. So the first pair is this one. So for 0 0.1, we have 15.55. So something like there. Okay. Now I'm gonna speed up the video. Right, plot is complete. Let's draw a best fit line. It doesn't have to pass from 0, by the way. So something like this. Yeah, that looks good. Okay, so we have a line of best fit. So, okay, we're done. Let's move on to part 2. Okay, so in part 2, we are basically rewarded for the plot we just plotted. So they give us the following equation that can be used to determine the wavelength of lambda, the wavelength lambda of laser light. So S is lambda W over W. So this has the form lambda D times 1 over W. And we see that the gradient of the plot of S versus 1 over W is equal to lambda D, and they give us the D to calculate lambda. So we have to calculate the gradient pretty much, okay? So you can come here, and I used this. You can use any points you want, but I used these ones from there to there, and then there. Okay, so this is delta S, and this is delta of, of 1 over W. Okay, let's go back here. So lambda is basically 1 over D. So actually, let's write that lambda D is equal to the gradient, so I don't confuse you. So lambda D is the gradient. Therefore, lambda is 1 over D times the gradient, or 1 over 9 times delta S over delta of 1 over W. So that's 1 over 9, which is D. And then we have 0.4 times 10 to the negative 3 meters in the numerator over delta of 1 over W, which is 76.34 minus 15.55. And this is in meters for the D, and then meters in the numerator as well. So this works out to 7.31 times 10 to the negative 7 meters, which is about 730 nanometers. Okay, and do they quote the laser used? Okay, so this is kind of infrared, but okay, I assume he used or she used the red. So this is red. Okay, all right, this was part 2. C. Another student carried out the same experiment using a different laser labeled with a wavelength of 520 nanometers. She measured W several times for the same value of S. The results are recorded below. Calculate the percentage uncertainty in the value of W. Okay, so they give us the mean value anyway. So the half range, which yields the absolute uncertainty, is the extreme value is 24 minus 20 over 2, so 2 millimeters. So the percentage uncertainty is 2 over 22 times 100. This is 9.09, which is about 9%. Okay, now question 2. Assess whether the student's results support the value of the wavelength of light given on the label. Okay, so first of all, they give us how S is related to lambda, D, and W, so we can solve for lambda. So lambda is WS over D, so that's 22 times 10 to the negative 3 which is W mean, okay, I take it from there, times S 0.2 times 10 to the negative 3 over D, which is 9, and this is in meters. So lambda is 488.9 nanometers. Okay, now we have to find the percentage uncertainty in lambda and see whether this makes sense. The percentage uncertainty in lambda is equal to the percentage uncertainty in W plus the percentage uncertainty in S plus the percentage uncertainty in D. Okay, because we have whenever we multiply physical quantities and then divide, we add the percentage uncertainties. I have a video on uncertainties. Go search my video library and you will find it. Okay. Now the percentage uncertainty in W is 9. Let's use 9.1%, which is what we calculated earlier. The percentage uncertainty in S is given as 4%, and the percentage uncertainty in D is not given, but we can calculate by 0.01. We can divide the absolute uncertainty with the value multiplied by 100, and I will need a clean page. So the result is 13.2%. So the percentage uncertainty in lambda is 13.2%. Now the absolute uncertainty in lambda is equal to the percentage uncertainty in lambda times lambda. So 13.2% times the value we just calculated, which is 488.9. So this yields 64.59 nanometers. So lambda is going to be 48.9 nanometers plus or minus 64.59 nanometers. So if we add, we find lambda max is equal to, let me add that because I didn't actually. So 488.9 plus 64.6 pretty much. So 553.5 nanometers, and lambda minimum is, we find that by subtracting 64.6 from 488. Actually, let me write this as 6 so I don't confuse you. So let's make this 6 and then 6. Okay. So if we subtract, we find 424.3 nanometers. So the value is okay because 520 nanometers is within the range. So student is okay. All right. And this was the AS level paper 1 from the Edexcel curriculum, the English curriculum. I hope this was useful. It's the first time I'm solving these papers, so they are almost the same as the international Edexcel curriculum, but slightly different. So forgive me if I'm making some mistakes. If something is incomprehensible, let me know in the comments, and I will help you. I hope these videos are useful. Please like and subscribe, and I don't know, tell your friends, something like that. So spread this video to whoever might need it, and hope I will keep making these videos. See you guys.